So I'm going to go ahead and derive the kinematics equations of motion. And the reason I'm doing this is I want you to see that these four equations are they're not pulled out of thin air. They're actually come from very specific places. So the two main places they come from are just these definitions of velocity and acceleration, where velocity is the displacement over time, acceleration is the change in velocity over time. The third component that's needed is a simple idea of average. So let's say we have an average velocity. Let's say we start from 0 and then we speed up to 10, and I asked you what's the average velocity, and you would say, well, 5, right? 0 plus 10 divided by 2. So we could write this as v initial plus v final over 2. And that would be what our average velocity is. Okay, so let's go ahead and derive the four equations. The first equation actually isn't really a derivation. It's just this equation right here kind of expanded. Remember, a change is the difference between the final and the initial. So we could write this as v final minus v initial over t. And then if we rearrange this, it gets placed into the form that we're familiar with, where vf equals vo plus at. Okay, so that's just, really this equation is just a restatement of the definition of acceleration. Okay, the next thing we're going to do is we're going to go ahead and substitute. We're going to say, remember, this v is v both for instantaneous or v for average. So if I take this equation and simply substitute this into here for v, what you get is something like this. Delta d over t equals v initial plus v final over 2. And if we then go ahead and multiply both sides by t, we get delta d equals vo plus vf over 2 times t. So this was our equation of motion number 2. And again, all this is the kind of the combination of this v average definition and the definition of velocity. So to get the other two equations, we're really just going to combine these two right here. So for the first one, what I'm going to do is I'm going to take this v final, I'm going to go ahead and substitute it into this v final over here. So we'll go ahead and write this as delta d equals vo plus, and then we're going to make the substitution here, vo plus at. So this is the substitution of this vf right here. We'll divide it by 2, and then we're going to multiply that whole thing by t. And at this point, we're just going to go ahead and do a little bit of algebra here. vo plus vo equals 2vo, so that's 2vo plus at over 2 times t. Okay, and let's go ahead and separate out this 2 here, and at the same time, let's go ahead and multiply by t. So for example, this is going to give us vo t divided by 2, right? Plus, and then we have at times t divided by 2. So we're going to write that as 1/2 att, or at squared. And that gives us our delta d equals. So that's our third equation. And again, that's just combining these two. And these two just came from the simple definitions and the concept of average. Okay, let's go ahead and do the third one. The third one, we're again going to combine these two equations that we have over here, but I'm going to put this one in a slightly different form. Okay, so what I'm going to do is I'm going to rearrange this right here into solve it for t. So I'm going to get vf minus vo, so to subtract by vo, and then we're going to divide by a, that equals t. So this is just this, right? But we solve for t. And then what we're going to do is we're going to substitute in the t into this equation. Okay, so that's going to give us delta D equals, so we'll just write this out, VO plus VF times 2, and then we'll go ahead and write this one out. VF minus VO over A. Okay, and then we're just going to go ahead and solve this. So the first thing I'm going to do is just pull out the 2A here. And then we're just going to have VO plus VF times VF minus VO. Remember back in 8th grade where you learned the FOIL method? So we're going to go ahead and use that here. So VO times VF, that's our first, right? VO times VF. Outside, which would VO times negative VO, so we're going to get negative VO squared. Inside is going to be VF times VF, so plus VF squared. And then last is going to be VF times negative VO. So it's going to give us negative VO VF. So it looks like a mess at this point, but it's really just algebra. Notice that this is VO VF and this is minus VO VF, so that's nice. That cancels out. And so what you're left with is, well, what we're left with. Let's go ahead and multiply both sides by 2A to get rid of this. So it's going to give us 2A delta D. And then let's write this. This is negative VO squared plus VF squared. And the form we usually write this in, we'll add VO squared to both sides. So that's going to give us 2A delta D plus VO squared equals VF squared. If you look at your equation of motion equations, you'll see that this was number 4. Okay? So anyways, I wanted you guys to see the derivations. I wanted you to see that those 4 crazy looking equations, okay, are really just come from these 3 equations here. The 2 definitions of velocity acceleration, and then the concept here of average.